My name is Reetam and I am here to present our project Universal Switch Set with Data Encryption and Decryption for Legacy Applications. Our team, which includes Kavya, Ayush, Pranav, Aditya, and Ashley ma'am, and myself Reetam operates under Team ID 37509, focusing on SIH PS 1727. The problem we are tackling arises from the current limitations in metro systems, where OEMs install switches that are bound to specific MAC addresses. This configuration makes it challenging to install or upgrade different switches without compromising cybersecurity. Retrofitting these systems with modern security protocols can be both challenging and costly, especially for organizations with limited resources or technical expertise. To address these issues, we propose developing a universal switch set equipped with data encryption and decryption capabilities that can be seamlessly integrated into various legacy applications that currently lack cyber safety measures. This switch set will provide a standardized interface for encrypting sensitive data before transmission and decrypting it upon receipt, significantly enhancing the security of legacy systems. It will support industry standard encryption algorithms to ensure compatibility across a wide range of applications, making it easily configurable and customizable for diverse encryption requirements. Our solution also includes robust key management features that securely generate, store, and distribute encryption keys to authorized users, thereby preventing unauthorized access to sensitive information and ensuring data integrity. The modular design of the switch set, which comprises encryption decryption engines, key management systems, and integration interfaces, allows for seamless integration with existing infrastructure with minimal configuration and customization. What makes our solution particularly futuristic is its adaptability to emerging technologies and standards. As industries move towards IoT and smart systems, the need for secure, scalable solutions become paramount. Our universal switch set is not only designed to meet today's requirements, but also equipped to evolve with future technical advancements, ensuring long-term viability. By retrofitting legacy applications with our universal switch set, organizations will be able to protect sensitive information and meet regulatory compliance without incurring the high costs associated with system upgrades or replacements. This innovative solution fundamentally transforms how organizations can enhance their cybersecurity posture while maintaining operational community. Thank you for your attention, and I look forward to discussing project further.
So our solution is the universal secure switch set addresses the problem by implementing several advanced security features. That first one is the quantum safe encryption. Our system include encryption method that protect against the potential threat posed by future quantum computing technologies, ensuring long-term data protection. The second one is the blockchain-based key management. We use a decentralized blockchain system to manage encryption keys securely and transparently. This ensures that the keys are protected from tampering or unauthorized access. The third one is AI-driven anomaly detection. The system has safely repairing encryption capabilities, which means it can detect potential threat in real time and automatically respond using AI-driven anomalies. The fourth one is the dynamic encryption. Our solution adapts the encryption strength according to the network condition and the sensitivity of the data, ensuring optimal performance without compromising security. Then fifth one and important is the multi-layer encryption. The system uses RSA and AES 256 algorithm, which are industry standard for strong encryption and decryption, ensuring that all data is securely transmitted and received. So overall, this solution provides a cost-effective way to enhance the cybersecurity of existing legacy system without requiring a complete overhaul of the infrastructure. It integrates seamlessly with current application while ensuring the sensitive data is always protected.
The next comes the technical approach, in which first the system is initialized, system setup, then config, then parameters, initialization of the universal set, then configuration of encryption parameters and protocols, then is the data interception, intercepting data packets from legacy applications, then network monitoring to ensure data is captured, and then data encryption, where encrypting intercepted data using AES 128 or 256 bit or RSA algorithms, key management via Pi cryptodome for secure key storage, then data transmission, it first encrypted data, then HTTPS, then API endpoint, secure transmission of encrypted data over the network, RESTful API requests handled by Flask or Django. Then comes data storage. The data flow is encrypted data, then MongoDB, and then data storage. The encrypted data is stored in MongoDB for scalability, and data model defined using Mongoose for structure. And then comes data retrieval. The data flow is MongoDB to API and to decrypted data. We retrieve data via MongoDB queries for specific records, and API serve data in JSON format upon request. And then comes data decryption. The encrypted data is then moved through AES or RSA algorithms. Then the data is decrypted. The decrypted data using the same AES and RSA algorithms, then controlled access to decryption keys for security. Then comes data output. The data flow is decrypted data to legacy application, presenting decrypted data through legacy application, and structured displays in JSON for output. And then comes monitoring and logging. Activity data, Prometheus to ELK stack. We activity monitor the activity through Prometheus for real-time analytics, and then centralized logging with ELK stack for data insights. Then finally system feedback, the system logs, then users metrics, then feedback, collecting performance feedback through system logs, then analyzing usage metrics for optimization. And then comes universal switch set with system architecture, the legacy application integration. The purpose is to connect old systems with new security. Then come modular encryption components. The purpose is to protect sensitive information. We use the technologies AES 256 and RSA, and the libraries PyCryptodome for Python and Bouncy Castle for Java. Then comes key management system, which securely handles the generation and storage of keys. The purpose is to ensure only authorized users can access keys. The technologies use Hyperledger Fabric for a secure blockchain ledger, and cloud storage AWS 3 for key storage. And then comes data transmission protocols, which ensures secure data transfer. The purpose is to safeguard data during transmission. The technologies used are TCP/IP for reliable communication, UDP protocol for faster, less relevant transmission. And then comes key management system. The key generation, first comes key generation, where we create secure keys using both asymmetric and symmetric encryption. The purpose is to create strong keys for encryption. The technologies we are using are PyCryptodome for key generation and RSA and AES-256. Next comes key storage. We use blockchain for security and integrity. The purpose is to ensure keys cannot be tampered with. And technologies used are Hyperledger Fabric for secure immutable storage and smart contracts to manage key lifecycle. Next comes key distribution to authorized users. We safely sharing keys with those who need them. The purpose to control who can access sensitive information. Technologies used are HTTPS and TLS for secure transfer of keys, and JWT for user authentication. Next comes key rotation and expiration management. The purpose is to minimize risk from compromised keys. The technologies used are automated tasks using cron jobs. Next comes data encryption and decryption. The data input, the purpose is to gather data for encryption. Technologies used are JSON XML for structured data and REST APIs for easy access. Next is encryption engine, because the purpose is to protect data from unauthorized access. Technologies used are libraries, PyCryptodome for implementing AES-256 and APIs for integrating with other systems. Next, from data transmission, the purpose is to safely transfer the encrypted data to the intended recipient. The technologies we are using are TCP/UDP for communication, MQTT for lightweight messaging. And next come decryption process. The purpose is to decode the received data back to its original format for use. The technologies used are PyCryptodome for decryption and PostCheck for integrity validation. And next, finally, the implementation methodology. System implementation. The purpose is to develop core functionalities and services for data encryption and decryption. The technologies we are using are Python, Java, and frameworks are Flask. The integration testing, the purpose is to validate the interoperability of components and ensure functionality. The technologies we are using are PyTest for unit testing and CI/CD Jenkins for automated builds. Next comes user feedback loop. The purpose is to engage users for feedback and enhance the system based on their experience. The technologies we are using are Google Forms, and for issue tracking, we are using Jira. Next comes deployment and monitoring. The purpose is to deploy the solution and ensure operational efficiency and security post-launch. Technologies used are containerization, Docker. For cloud hosting, we are using AWS, and for performance monitoring, we are using Prometheus. So this was the technical approach.
Moving forward to feasibility analysis, first is technical feasibility. Established technologies such as encryption algorithms and APIs ensure compatibility with legal systems. Modular design enables easy integration, customization, and deployment in diverse environments. The next is an economic feasibility. Retrofitting provides a more affordable solution compared to the expense of overhauling entire systems. Using open source technologies cut down on software license fees, making the project more budget friendly. By reducing security breaches and avoiding compliance penalties, there is potential for substantial long term cost savings, incidents, and compliance penalties. Now, the potential challenges and risks, integration complexity. Legacy systems with varying architectures can pose challenges during integration. Next is user adoption. Resistance from users familiar with current processes may slow down the implementation. Third is data privacy concerns. Meeting regulatory requirements for encryption and key management, such as GDPR and HIPAA, is critical. Performance impact. The encryption and decryption processes may introduce latency, potentially affecting systems performance. Now, to overcome these challenges, we have the following strategies. The first is modular integration testing. Use JUnit for unit testing and Postman for API testing to verify the functionality and compatibility of each module. Next is change management and training. Develop a change management plan that includes stakeholder involvement and training programs through simulations and practical workshops. Third is regulatory compliance and risk mitigation. Implement compliance management software like Logic Manager to ensure regulatory adherence. We're conducting ongoing risk assessments with tools like RiskWatch for proactive monitoring. The last one is performance optimization techniques. Utilize profiling tools like JProfiler or Visual VM to detect performance bottlenecks and improve data processing efficiency by implementing caching solutions such as Redis.
When it comes to the impact and benefits which are being provided by a project, let's first talk about the potential impact on target audience. First of all, we are going to be using a very enhanced cybersecurity environment. So we aim to protect sensitive metadata from cyber threats, ensuring system integrity and safety. And the project is also going to be increasing the trust of the target audience. So our solution fosters user confidence and regulatory trust by prioritizing data integrity and confidentiality. And when it comes to operational continuity, we are trying to minimize the system downtime and breaches, and also we ensure uninterrupted service for millions of commuters. And when talking about the benefits of the solution, there are various kinds of social, economical, and environmental benefits. Talking about the social benefits, there will be an improved public safety, and there will be an empowerment of the user. Talking about the economical benefits, it saves lot of costs, preventing data breaches, reduces fines and reputation damage, and resource optimization is also being done by project, and the efficiency will be boosted enormously. So modern security improves overall system performance. And talking about the environmental benefits, sustainability will be provided and low energy consumption. So streamlined process reduce energy usage and carbon footprints.
To support our solution, we have based our approach on extensive research and trusted technical resources. The first one is our research has been guided by academic and industry sources such as MIT Technology Review for insight into securing legacy system with modern encryption. Then IEEE General for understanding the challenges of cybersecurity in public infrastructure. Then ACM Digital Library for exploring option for legacy system in cybersecurity context. The second one is for technical implementation. We have rely on widely recognized standard. The first one is AES Advanced Encryption Standard documentation from NIST. Then second one is RSA encryption and key management protocol. The third one is the GitHub resources to ensure that our encryption method align with open sources best practices. Then third, additionally, we have follow security framework and guideline provided by the NICT cybersecurity framework, the ISO IEC 27001 standard for information security, smart city cybersecurity guidelines from ENISA to ensure our solution is compatible and critical infrastructure. These resources ensure that our solution is not only technical feasible but also compliant with international cybersecurity standard, providing both short-term and long-term security benefits. Thank you.
Thank you, team. This was our solution for the problem statement in the SIH 2024.